Every day, commercial buildings generate thousands of data points from sensors, weather systems, and HVAC equipment. Yet, despite all this information, they have no memory. An anomaly happens, an engineer manually fixes it, and by the next day, the building has forgotten everything it has learned. That's the problem Project Mnemosyne solves. This is the live operations dashboard. Throughout the day, Mnemosyne continuously monitors building telemetry, including power demand, weather conditions, and indoor comfort. As the day progresses, the building behaves normally, but at 2:30 p.m., an unexpected demand spike appears. Instead of immediately changing the HVAC controls, Mnemosyne simply observes the anomaly and records it for investigation. When the building becomes idle at night, something unique happens. Instead of doing nothing, the building enters what we call the dream state. Here, an autonomous AI agent reviews the day anomalies and begins thinking like a scientist. Rather than guessing solutions, it generates a research agenda consisting of testable hypotheses, such as can pre-cooling be reduced on overcast afternoons without affecting occupant comfort? Each hypothesis is then translated into an energy plus building simulation. Most importantly, the AI never interacts with the live HVAC system. Each proposed optimization must first pass deterministic physics validation using energy plus and ASHRAE 55 comfort constraints. If a hypothesis violates physical safety or occupant comfort, it is rejected and permanently recorded in a failure evidence ledger, ensuring the safe-unsafe experiment is never repeated. Only the validated discoveries move forward. Here you can see the agent is looking at different queries in the agendas which are queued. It will look at each one of these separately and then it will validate them. This can be also shown in the code where we can see that the agent is running hypothesis. We have used the Grok API for this process. So, successful experiments become permanent discovery records. Instead of storing raw sensor values or temporary set points, Mnemosyne stores reusable causal knowledge, capturing the original question, the validated hypothesis, simulation evidence, confidence score, and estimated energy savings. In other words, the building no longer is just operates, it continuously learns. The final innovation is the fleet intelligence. Imagine a newly commissioned building joining the network. Instead of spending hours or years rediscovering the same operational knowledge, it compares its architectural profile with existing buildings. Once a compatible match is found, it instantly inherits validated causal values from similar buildings. Knowledge, not raw parameters, is transferred, allowing every building in the fleet to benefit from the experience of others. Buildings today generate enormous amounts of data, but they forgot every lesson they learned. Project Mnemosyne transforms buildings from reactive control systems into autonomous scientific systems that observe, hypothesize, validate through physics, and permanently remember.